Something that I hope you find a little bit fun and refreshing, because I'm not going to talk about the regulatory environment and how to invent devices and things like that, but instead provide a little bit of insight about the future developments of our field and where our field is going, considering the significant amount of changes that we have, the social, political, and healthcare changes. So I want to start with a little bit of a historical context, because I see that in all the meetings, everybody quotes, Andreas Gronzig as the person who, truly started, our entire field. And they show the first coronary balloon angioplasty in 1977, which no question was perhaps the pivot point of our field, and created something that is very special that we all benefit from at the present time, which is the interventional cardiology field. But I am never tired of actually learning about the true innovators. And for me, at least personally, the biggest hero is actually Werner Forsman, which at the beginning of the 1900s, actually against his own institution, put a catheter through his arm, essentially took an X-ray and went to document the first cardiac catheterization. And I really think he's the one that we need to, say thank you for, because he was a real pioneer that essentially showed, as he called it, the gate, to the heart. So you guys know he's perhaps the only one that actually got a Nobel Prize, and perhaps the only one that is going to get a Nobel Prize in our field for these, development. Later on, one of the things that, I feel that we have lost a little bit is the basic science and translational research behind what we do. And I'm quoting 3 beautiful papers that were published in the 1980s and 1990s that essentially showed, with a high degree of, exquisite taste, the mechanisms of failure of balloon angioplasty. And were these results that essentially inspired, innovators and inventors to develop the stent. And you actually see 2 amazing moments in our field happening in Brazil in 1988 and 1999 with the introduction of the bare metal stent and the drug-eluting stent. Since then, a lot of things actually have changed, and it's something very interesting happening right now in the management of coronary disease. And I really think has to do with imaging and the introduction of artificial intelligence. And is the capability to essentially have a very highly accurate, non-invasive diagnosis of coronary disease. And more we see the diagnosis, staging, and planning of coronary disease is happening as an outpatient basis. So the need to take patients to the catheterization lab to at least diagnose disease is going to actually decrease substantially over time. Also, the use of wires and actually medications to assess physiology in the patients is actually also decreasing significantly. And with the amount of tools powered by artificial intelligence, we see more use of wireless physiology assessment tools that simplified the cath lab management and diagnosis of these patients. When you go to the interventional side of things, we see a massive amount of development on software automatization, in which pretty much the idea is to provide a full analysis to the operator, so the operator selects the right stent, the right diameter, and the right application of the tool they're going to use. So we will see and continue to see a revolution on imaging that is going to really make the diagnosis simpler, faster, and actually more automatic. One thing that we started to see, and is actually quite interesting, is that coronary intervention is finally embracing the concept of leaving nothing behind. And latest numbers coming from strategic companies started to see there is a decline of metallic stent use in certain parts of the country, especially actually Asia. And the reason is because now we have improved performance of lesion preparation devices, such as actually intravascular lithotripsy, and we have already at least 3 or 4 companies coming behind with advanced systems that actually can produce better and actually more efficient and safer balloon angioplasty that we had before. We also have better assessment of PTI outcomes, and we can really discriminate if the patient has an occlusive dissection or actually, where the patient essentially needs to be stented or not. And we have now a wide variety of advanced drug delivery balloon platforms that we didn't have before in the 1990s. So I would actually say that the PCI definition is going to slightly change in the future, and this is actually kind of my proposal. Prepare the lesion, confirm physiologic patency, and individualize the use of a stent. I really think in the future, I predict the spot stenting is going to actually be a very interesting option, especially patients with significant calcific or diffuse disease. The invention of the stent was the catalyst for the development of other catheter-based technologies. And if you actually look at the history of our field after the invention of the stent, pretty much everything came behind. If you look, the first percutaneous aortic valve was essentially developed by a group of stent developers and was inspired by a stent technology. And everything started actually from there with the idea of actually making interventions less complex and actually improving of procedural outcomes, fast procedural recovery, and early hospital discharge. And for all these technologies, in order to be successful in the future, miniaturization, making these devices smaller is a must. Simplification of the procedure is extremely important, and standardization of the procedure as well is the goal. And as I said before, TAVR was a spin-off of the stenting era, and actually everybody here knows the story. After more than 2 decades of research right now, the technology actually has grown and expanded into areas that we never expected before. But you see the field continues to essentially evolve in this field, and now you see systems that actually are tested and right now already in first-in-human studies, like this Seagull system, that is an 8 French fully loaded TAVR device that, as it happens in stents, using a dedicated different type of metals, in this case is rhenium, that actually is a very strong metal that allows the frame to be extremely thinner and achieve the same radial force as conventional devices, and they have been able to go down to 8 French. So imagine in the future being able to do full-blown TAVR procedures with 8 French fully loaded devices. Also, these technologies allow us to go into areas that we never explored before, and one is the possibility to treat mitral valve disease with a fully blown valves. And this is actually a remarkable achievement that has still a lot of challenges, ahead of us, and actually a lot of studies need to be done, but essentially promise the potential to be able to treat patients that are high risk for surgery with fully percutaneous technologies. And you actually see how these catheter-based techniques have expanded to areas that we never thought before. And I here put a simplified list of the mitral and tricuspid technologies that right now are under development. That actually shows you, the creativity of engineers and inventors, but actually also the aggressive appetite of investment in fields that are extremely exciting for this type of people. Also, the catheter-based field has migrated into a new field that we call interventional heart failure, trying to replicate some of the surgical techniques or interventional techniques to improve myocardial performance. And this is actually another completely different field with extremely exciting, ways to essentially try to treat the failing heart with mechanical methods, including mechanical circulatory support. But one of the things that actually happening that is very interesting is the adoption of these catheter-based procedures highly depends on the evolution of cardiac, imaging. And the introduction of new imaging technology that are simple to use and interpret will serve as the expansion platform of catheter-based technologies. The reality is there's limited access to highly skilled imagers. And if you actually look in the United States, across around 2,000 departments with interventional cardiology, only 18% of these sites actually have very well-developed structural imaging departments. So you see there is a big gap in terms of what is actually available right now and what is actually needed. This gap is even larger if you go out of the US in areas like Latin America. To find real expertise on imaging guidance is extremely difficult. So the technologies are actually evolving, trying to close this gap, and this is one of the examples of how this is actually happening. This is a company that essentially is teaching people or guiding people to do echoes, high quality echoes without the need of actually having a skilled operator, to do the procedure, for the patient. Essentially what it happens is you activate the software, and the software essentially tells you exactly where to go, what to do, what images to capture. So pretty much a nurse, a technician, or anybody can actually capture all the images that you need. These images can be transferred, and actually also there is a component of automatic, software that can read in a high level of accuracy the echocardiographic findings. So as you can imagine, this could potentially really be helpful in areas in which skilled operators are actually needed, but they are not available. So you can actually upscale the number of procedures that actually are done in these particular areas of the world. Also, this is another way to essentially replace the skills that we don't really have right now. And there are at least 3 companies I know of developing fully independent, robotically operated TEEs with the idea of actually doing TEEs remotely, or essentially decreasing the dependence of the operator to be in the room, being able to actually be outside doing the TEE and go to a different room, which actually also allows a lot of flexibility and increase the possibility of doing more of the procedures in remote areas. But changes in the practice of medicine impact the future of the interventional cardiology field, and especially health economics is a big driver in everything that we do, and cost effectiveness of therapeutic interventions has become one of the most important things, in our field, today. So recovering patients quicker, having better procedural outcomes and early hospital discharge is really becoming a very, very important drivers of innovation. That's why actually remote patient monitoring and keeping the patient at home is going to become an extremely important part of what we do on a regular basis. Also, predicting therapeutic response, so this concept of personalized medicine is becoming extremely important. So you not only keep the patient at home, but actually also select the patient that can benefit from certain specific therapy. That's why in the next 10 years, and it's happening already, I see this pattern of what I call the centralization of patient care. And there is a proliferation right now of remote ICU monitoring hubs in which you actually have a specialist not going to the hospital, but going to a centralized hub in which they can manage multiple ICU units in having a multiple actually screens at the same time. Already in New York, there is a company doing this. Companies doing remote virtual diagnosis, especially for imaging, CTs and MRIs, remote ventilatory control, and obviously remote robotic interventions. Also, as we have actually seen with all the technologies during this meeting, you may have 3 patients with similar anatomy, they do not respond the same way to therapy. So there is a lot of work on personalized medicine and actually trying to predict patient response in these patients. We are not actually all the same, and we respond in a different way. And that's why I believe that all these data acquisition methods, invasively and non-invasively, is going to actually help us to identify the non-responders and responders phenotypes with the use of artificial intelligence. There are actually also exciting development on the invasive front, and this is a project that actually I'm part of, and this is an experimental implant of microsensors that essentially turn implantable devices into real-time physiologic monitors. You see here with a catheter, we're putting a sensor in the left mitral annulus. The sensor is actually extremely small. The sensor doesn't actually need a battery because it works as a drum with actually movement and can continuously actually sense, pressure in the left atrium, right atrium, and actually even the brain. Imagine if you can integrate these sensors in implantable devices, you pretty much actually end up with a Swan-Ganz, forever and actually use this information when it's transmitted via phone to be able to make decisions for these particular patients. Which is even more exciting is with the collection of all this data with watches and wearables, companies are developing this concept of digital biomarkers or bloodless blood tests. When you actually collect eye movements, respiratory response, movement, walking distance, and all these things, you can actually create a lot of biological biomarkers that can help you to predict recurrence, rehospitalization, and actually functional status in these patients. And there are already several companies developing digital biomarkers based on all this information that actually they are getting. Limited access of care is one of the big things, right now everywhere, including actually the US. We develop amazing tools, but not all the patients, I would say the great majority of the patients do not really have access to them. As an example, this is the US, the barriers to stroke care in the US. Timely treatment is critical, as you know, for stroke victims. In the US, only 20% of the US population can have access to a stroke center capable of actually doing thrombectomy in 15 minutes or less. So this is actually quite remarkable, and it's actually even worse in different parts of the world. And that's why actually the concept of remote intervention, having highly qualified people working on centralized areas that can treat not all conditions, but actually critical conditions in which different specialists cannot be available, such as neurointerventionalists, make a lot of sense. And I understand there is actually a program in India right now on tele-intervention, especially for neuro, which is actually very exciting, promising, and could potentially change the way that we treat patients in the future, because it's a reality. So in conclusion, I really think there has never been a better time to be a cardiologist. I mean, you can actually take many potential pathways, not only from the coronary side, but also on the structural side, interventional heart failure things, or actually even start working on a digital healthcare, which is going to become a big thing in the next 20 years. But one of the things that actually I always think about, especially for the new generations, is that we are actually also going to face a lot of challenges. We're bringing new people, to this field that need to interpret complex anatomical abnormalities using 3D imaging, adopting techniques that don't learn during training, navigating catheters in unfamiliar anatomical locations, but at the same time, they have limited access to specialized training, opportunities. And that's the reason why I believe meetings like this are extremely important to actually fill the gap and essentially help this new generation of physicians to get better training and better understanding about what is actually coming next. Thank you again for the opportunity, for allowing us to participate here. I invite you actually also finally to go and look at this platform that is actually called CRF Connect, that is actually free, and it's got all the academic content presenting our meetings, highly curated in an easy way to find, and it's a very, very cool, Netflix-like platform that I think you can enjoy, and it's going to help you to promote and enhance your education. So thank you very much again for your invitation, and I'm going to stop here in case you have any questions.